Alright, problem number 5 says that at Hogwarts School, every student is friends with at least one other student. Can it be proven that there must be at least 2 students who have the same number of friends? Alright, well, my hint to you, I think, is I'm going to tell you something obvious that you can use as an analogy of for this problem. And that thing that I want to tell you about is called the pigeonhole principle. So what's the pigeonhole principle? The pigeonhole principle is basically that if you have, say, n pigeonholes, so if you have, actually, if you have n pigeons, and you have n minus 1 pigeonholes, then when all those pigeons fly back to roost in their little pigeonholes, then the first n minus 1 pigeons are going to find holes where they can be independently, and the last guy is going to have to room with one of these other guys. So what the pigeonhole principle says is that if you have n pigeons and n minus 1 pigeonholes, then one of the pigeonholes is going to have to contain more than one pigeon. Okay, so at least one. Okay, now you could actually get, maybe 2 in this one and 3 in this one, and so here we have 10 pigeons and we have 9 holes, so this guy doesn't know where to go, so he's going to have to go with someone else. But you could get the situation where you've got 2 and 2. Maybe some of these pigeons like to be together. Maybe they're mates, so you but you have to have there has to be at least one pigeonhole that is going to be occupied by more than one pigeon. Okay? That's the pigeonhole principle. So the trick in this problem is to find an analogy between the pigeons and their holes and the students at Hogwarts and their number of friends. Okay? So we can make an analogy where pigeons is to pigeonholes as I guess you have students is to number of friends. Okay, so see if you can find an analogy, or see if you can find a way of using this principle of pigeons and holes to relate the students with their number of friends. Okay, that's my hint. So let's go ahead, I'm going to scroll back up here and solve the problem. Get up here where we can see the problem. Let's see. Okay, I'll keep the pigeons up, I guess. Alright, so we have Hogwarts School. Let's say we have n students. Okay, just like we had n pigeons down here, we have n students. Now, what are the possibilities for numbers of friends? If we were to take all of these kids and ask them one by one, how many friends do you have, and then sort them out according to their number of friends, they had to have at least one friend. So they could have one friend, they could have 2 friends, they could have 3 friends, all the way up to n minus 1 friends, right? Because if someone's friends with everyone, I guess we're not counting themselves as a friend. So they would have n minus 1 friends if they're friends with everyone. Okay, so the possibilities for the number of friends is 1 to n minus 1. So we essentially have n minus 1 possibilities for the number of friends. So this is number of friends. So once you have that, you see how that relates to pigeons and pigeonholes? So essentially the pigeons are the students and the and the pigeonholes are the numbers of friends. Okay, so we're like, we're sorting them by number of friends, and we only have n minus 1 categories to sort them into, so some category is going to have to be filled by more than one student. Okay, so the answer is yes. We can prove that at least two students have to have the same number of friends. Okay? Alright, so I also asked you a bonus question. The bonus question was, what if we didn't have this restriction where where each student is friends with at least one other student? Let's say for example that a student could have 0 friends. So so then we still have n students, but this time the number of friends could be 0, it could be 1, it could be 2, it could be 3, all the way up to n minus 1. Whoops. N minus 1. Alright, so now it kind of looks now like we have n categories to sort the kids into if we were sorting them by number of friends. But we need to think about it. If someone has 0 friends, then we can't have someone with n minus 1 friends, because if someone has n minus 1 friends, then they're friends with everybody. So this poor kid over here with no friends has to have a friend, because the person with n minus 1 friends is a friend of that person. So we can't have both. We can't have 0 and n minus 1. By the same token, if someone has 0 friends, then then this guy over here can't have n minus 1 friends. So we either have the case where we've got 0, 1, 2, 3, all the way up to n minus 2, which is n minus 1 categories, or we have the situation where we have 1, 2, 3, all the way up to n minus 1 numbers of friends. Okay? Because if someone has n minus 1 number of friends, then every student has to have at least one friend. Okay? So either way, we have n minus 1 pigeonholes to put our n students into. So that means either way, this statement is still true, that at least 2 students have to have the same number of friends. Alright? That's what I love about math. The reason I gave you this problem was a lot different than other problems I've given you. This is more of a proof problem. But the thing I like about it is that, you take something obvious, like this pigeons and holes, and you can apply it to figure out more complex things. Math is just like that. When you're just a little tiny kid, you learn how to count, and once you know how to count, then you can learn how to add, because adding is just repeated counting. So if you start at 4 and you count 3 more, you're going to get to 7, right? So that's just addition. And once you know addition, then you know that repeated addition, like if I take 2 plus 2 plus 2, that's just 3 times 2, right? So multiplication is just repeated addition. And then when you get a little older, you learn about exponents. What are exponents? Exponents are just repeated multiplication, right? So 2 times 2 times 2, that's multiplication, but that can also be written as an exponent, 2 to the third. Okay? So that's the beautiful thing about math, is that you take things that seem really obvious, like pigeonholes or like counting, and you can build up to more complex ideas. So there you go. There's the pigeonhole problem and how we can apply it to the students at Hogwarts.